Alright, so here we are with graphing sine and cosine functions. First thing that we need to know is this sinusoidal idea. It's kind of that repetitive sound wave looking shape, and that's what we would represent as something being sinusoidal. Even if it's a cosine, we still call it sinusoidal. It's kind of the parent of the shape. So when we take a look at sine of x, one key feature that you need to remember about sine of x is that it starts at the origin and goes up. These are actually the same graph, only one of them happens to be shifted. But as we look at sine, it starts at the origin and travels up. Notice that the maximum height and the minimum height are one away from the x-axis. And then it does take one revolution within 2 pi in order to start repeating again. So one period is what we call it, lasts for 2 pi in a parent function of sine. Same thing happens here, it's just that the repetition would start at the top and go back down and up. And so again, one period is 2 pi for cosine, just like it is for sine. You'll also notice the maximum and the minimum are still one away from the x-axis. And so taking a look at our definitions down here, the sine equation starts on its axis of oscillation, so it starts here where that middle is that it kind of oscillates from. And it goes up from there if it's positive, but if we randomly put a negative down there, that would just mean that it would go down and up, kind of mirroring this. The next one here is cosine, and it starts at the maximum or the minimum. The minimum, of course, if it was a negative. But again, it starts at this maximum point, goes back down and up, and then it would repeat again, which is sinusoidal. And then down here again, period is 2 pi, meaning it will start to repeat itself after 2 pi before any phase shift happens. So it just means before it's shifted left or right or up or down or anything like that. Alright, so if we take a look at graphs of sinusoids, here's more of an extension of the sine graph. Again, we know it's the sine graph because it starts at 0, 0, goes up, and so this is actually 2 periods of length of the sine graph. When we take a look, and this is clear with every other function as well, remember there could be an a value out front and that would stretch something. It stretches anything as a graph that we're looking at. We also have this b value inside here, which could stretch or compress horizontally. The h value, remember, is the thing that shifts it left or right, and the k is what shifts it up or down. So we do have that general transformation idea that can happen with sines, just like it can with any other function. The amplitude is going to be the height. So you'll notice in the previous equations, it was sine of x. And so technically there is a 1 out front, and that 1 meant that the height reached a 1 at its maximum. But again, if we change that a value, it could make it so that it like in this one here, looks like it has a 4 out front, just because it has 4 tick marks here to reach to the top. Notice it says amplitude is the absolute value, because of course we're not going to say a height is a negative number. And so whatever number happens to be up front, the absolute value of it is going to be your amplitude, meaning the distance that it would travel from its point of oscillation, not the entire height. Alright, then we also have the period, and the period, as we saw in the previous, was 2 pi, and again that is because when we worked with sine of x, there is technically a 1 here. And so if we were going to take 2 pi over b, and b is 1, you'd end up with 2 pi again. So any value that might be inserted into this place here for b is going to be put in the denominator as its absolute value, so as a positive number, and it's going to change your period. So all that would mean is that it's going to change the length. So maybe it wouldn't circulate in 2 pi, maybe it would do it in half the time. Or in this case, I'd just make a third of the time. Alright. And then the frequency, and this is where period and frequency kind of get different. The period is the length of it, and the frequency is how often in 2 pi. So how often in one revolution would it repeat itself? So Just something to remember. The next thing here, just reading in, when compared to the graphs of a sine bx and y equals a cosine bx, so they've omitted the h and the k here, they also have the following characteristics. So a phase shift of h, meaning that it's going to, we call that a phase shift versus a translation. It's all the same. We just know that we're now working with a sinusoidal function, and so we call it a phase shift. And then we also have vertical translation, but again, that's your up or down shift with k. So just getting back to that idea of a, b, h, and k and how those shift, and then introducing this amplitude, period, and frequency of a sine graph. So to graph without a calculator, what you're going to have to do is plot the starting point. So the best thing to do with a sine, for instance, is to know that you're starting on the axis, versus a cosine, you're starting a units above. So if there's a 1 out front, it would be here. Then you're going to plot the end point. So 1 period away, you're going to put another point so that you know that that's where you'd need to end up at the end of one phase, or 1 period. Then you plot some middle points so that you can kind of connect them. Plot the middles of those middles, and then you get to, of course, connect them with a nice wavy line here. So let's see, our first example here, we're going to find the amplitude and period and then graph, and we're graphing on the interval negative 2 pi to 2 pi. So just so that we know, let's see, yep, over here is going to be 2 pi, so in the middle is going to be pi, in the middle of that is pi over 2, and in the middle of each of these is 3 pi over 2. Same thing's going to happen over here. We'd have negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. You could, of course, change this into degrees as well, but the idea was given in terms of pi, so we may as well say that. The amplitude of this is 3, and so that means we are going to have a height of 3. So if I look at this is 1, 2, 3 up here. So this is going to be our maximum and minimum. So it's kind of going to be, what's the word I'm looking for? Bounded by 3 at 3 here. Then it says its period is going to be 2 pi over absolute value of b, and our b value is 2. So it's going to be 2 pi over 2, meaning pi. So that means that it's going to go, in this case we're looking at sine, from the axis of oscillation, up, back down, and back to the middle again by pi. So if we're going to start here, as the directions say, we're going to end here, because again that's where the period is. We're going to plot the middle, which is actually where it's going to go back through the graph. And then since it's sine, it's going up. So this is its highest point it's going to reach. Through that middle, it's going to go back down. So that's the lowest part it's going to reach. And so here we are with our first iteration. Then, of course, we have to repeat that because they want it to go all the way through to 2 pi. So it's going to go up and back down. And then, of course, they want us to go all the way to negative 2 pi. So back down and up again, and back down through and up. Sometimes mine tend to look like V shapes versus that rounded shape, but of course that's just because of, maybe how fast I'm going, and like this point here where I kind of missed it a little bit. But the general idea is there, and it's best if you, of course, take the time to put some points in, so that if you can't flow through them nicely, at least I know where you're meant to go. So that is from negative 2 pi to 2 pi of that equation of 3 sine of 2x. Whoops. One thing that kind of drives me bananas about this is that they don't put the parentheses around here. I don't know why not. To me, it kind of groups it together and makes it a little easier to look at, but to each his own. So we're going to continue on here. We're going to find the amplitude, period, and then graph as we just did. So again, we're going from negative 2 pi to 2 pi. and we're doing negative 2 sine of x. So you'll notice that negative 2, or our amplitude of 2, means that it's going to be bounded at 2. So it won't go past those two red lines at all. And then the period is 2 pi over b, and our b is actually non-existent, and so it's 1. So our period is just 2 pi, meaning it's just going to be kind of stretched from what it normally would have been. So same period, it's going to go up, through, back down. Oh, we're doing sine, good, okay. So up towards our maximum, back through at pi, down and back up. So really we have just in fact graphed 2 sine. Oh, but now I've forgotten that there's a negative, which means that we're actually going to start by going down. All right, then going through the origin, we're going to go back up, down, and down and up. All right. The next one here, oh, they want us to go from negative 4 pi to 4 pi, so this is going to be negative 2 pi and negative pi, negative 3 pi and negative 4 pi, and then we have after 2 pi, 3 pi, and 4 of them. Okay, so the amplitude on this one is 4. We're doing cosine now, so we want to make sure that we understand that after being balanced on negative 4 to 4, we are actually going to start up here at the 4 versus at the origin. We also have this period issue of a half, so 2 pi over a half. Since it's a fraction over a fraction, it's actually the same as 2 pi over 1 times 2 over 1, meaning 4 pi. So that means that our period is 4 pi, which is kind of why they changed the range here. So it's going to go up and back down by 4 pi versus by 2 pi. And then this phase shift here is saying that instead of starting at 0, as I've made my point already, I'm actually going to, and remember it's opposites, I'm going to go left pi. So that actually means that my new purple dot is going to be up here. Since my period is 4 pi, that means 4 pi away, I'll put another dot. I'm going to erase this one. And then we are in fact going all the way down to the bottom here. So let's see. Yeah. So we're going to reach the axis after we go down here. Go all the way down to the negative 4, back through the origin and back up. And it tends to not look very sinusoidal when you start to graph like this, so just know that it is going to be arching and then arching back, arching up, arching back again, and then you can kind of mirror that. So this is going to go back down, this will go back down, so it is, yeah, and then up again. And so you can see that an entire period would last 4 pi within here, but of course it's shifted left. So it actually looks like negative sine, because it starts at the origin and goes down, which is actually a thing we need to know, that cosine and sine can be got by each other by shifting pi. Alright, so same things all over again, we're just graphing. So let's see, our amplitude has to do with the 3 there. So per usual, oh, apparently I don't have a graph that helps me out with that. I don't know why there's this thick line there suggesting that the origin is down there. Anyway, so we're going to have that as its minimum. The period is over 4, so we've got 2 pi over 4, meaning pi over 2, so that's going to be actually very short. So between 0 and pi over 2, it's going to do an entire phase, so yikes. The phase shift here is left pi over 2. So if the period's pi over 2 and it moves left pi over 2, it's not actually going to change it much, because it's just shifting it one within a phase, so it doesn't really matter. And then the vertical shift is up 2, and I guess that's probably why we have this graph. So up 2, and so now I get to change my red lines up 2, so up to 5, and then up 2, so to -1, which is why this graph looks like this. Alright. And then just to be clear, I'm going to kind of iterate that this is the middle of that phase. Alright, so let's see how I want to graph this. This is where you can actually make every single graph look exactly alike, because you can shift however wide you want it to be. So I'm just going to go with what we were doing before, which was that this is 2 pi. And so then this is pi, and this is pi over 2. It'll help us a little bit more when we're trying to fit all of these in here as well. And then, because it gets messy, I'm not going to label each of these. Alright. So we've got our amplitude. We know that we're doing, which one? Cosine. So that would mean that at the origin we would start up, or well, at the axis we would start up at our highest point. We also know that it's shifted left by pi over 2, but again, oh, it's actually right because of the plus and the minus sign. But again, if the phase shift equals the period, it doesn't actually alter much because it's going to have to go back up to that point anyway. Alright, so we're starting there. And then we know our period is pi over 2, so then it's going to end there. And then we already did up 2. So within this one moment here, we're going to have to go down, all the way down to the bottom, through, and back up again. So, alright. And so down to here, back up again, down through here, back up again. Yeah. Alright. You can also make your calculator make a table for you, but of course if you're doing it in radians like we're doing, wow, I only stopped at that line down there and I should have gone all the way down. Boo. I think I'll just do this as many times as I can. I went down to this black line, but it's the red line I was supposed to go down to. There we go. Again, as I was saying, you could make your calculator give you coordinates, but it isn't all that helpful when you're using radians, because you'd have to know the decimal equivalent of the radians. So it's not really that helpful. But it is nice to have the calculator graph it for you, so you can at least see kind of where you would start and how repetitive it is. Wow, that is a lot. And so just so that we can go back to frequency, because we haven't really had a lot of that, remember that frequency, where was our definition here? Yeah, frequency was b over 2 pi. So if we go to the one we were just on, our b value is 4, and so it's going to be 4 over 2 pi, which means that this happens, let's see, 4 over 2 is 2. Within a 2 pi, how many times is it repeating? 1, 2, 3, 4. Yeah, it's 4 times. So it's a lot, the frequency of 4 within a 2 pi. Alright. Oh, is that it? I guess it is. So your assignment is going to be very much like this. You're going to be looking at each of these, telling me if it's got an amplitude of a certain amount, what its period is, its frequency, and so you can kind of reference these formulas as you work through it.